So the beginning of this module starts with integration by parts. What you are going to learn in this module are complete integration formulas, how to integrate different kinds of problems. And the first one is how to integrate the product of two functions. So our goal in this module, in this section, our goal is to be able to integrate f of x times g of x dx. So we have two functions, f of x and g of x, and we need to integrate these. Okay, so for example, and this is why I did that little mini quiz, you may have to integrate x e to the x dx, or you may have to integrate x squared sine x dx, or you may have to integrate the tangent inverse of x dx. So all of these things are difficult integrals that we need to learn how to do. All right, so here's the formula. The formula is simple. Okay, the formula is simple, simple. All right, I'm going to derive it from the derivative formula. So suppose I have the derivative of two functions. One is u of x and the other is v of x. When I take the derivative of two functions, I get the first, the u, times the derivative of the second, dv, all right, dx, plus the first, derivative of the first, du dx, times the second, which is v. Okay, nice and simple. All right, so therefore, if I just use differentials, I get the derivative of the function u times v. I'm just using differentials, is u times the derivative of v plus v times the derivative of u. Okay, now I want to solve for u dv. So u dv is going to equal the derivative of uv minus v du. So I just threw this thing to the other side. Okay, so now I'm going to integrate. So I get the integral of u dv is equal to, when I integrate d, when you integrate the derivative, you just get the function back. So I get uv, and then I still have to integrate v du. So this right here is the formula you need to go home and memorize. Okay, not just memorize it, understand it. Okay, so I am going to do the integral of some function u that's multiplied by the derivative of another function v is equal to the product of the two functions. So I need to find out what u and v are, minus v du. Now, in order to do this, I'm going to use the case quarter method. Okay, that is, I'm going to define my functions, and then when I need to, I'm going to put them right back in as if I'm doing an exchange for a case quarter. If you weren't here yesterday, you find out what a case quarter is. Okay. All right, so the first example is so simple. Okay, this is one of the easiest ones to do. All right, here we go. So I want to integrate x times the sine of x dx. Now, 95% of these problems U is something that when you take its derivative gets easier. There's this one little 5% where when you take, where you can't use U to be X or X squared or something simple. So watch what I do. It's only two things. The whole thing has to be U dV. So if I let U be X, then this whole thing left has to be dV. Maybe I should have done the, it doesn't matter. Okay, there's only two parts to this problem, is U and dV. So if this thing is U, if X is U, then everything left in the problem has to be dV. Any questions about that? Ezekiel, you have a question?
We're basically going on the formula, yes? Because
We are using the formula. We're going to use that green formula so much today, you're going to be sick of it.
okay, I follow.
Okay. Now, I need V and du. So I always say, here's U and here's dV. Every problem starts off like this. Okay. Now I need derivative du. So what is du? This is why I had you do those quick derivatives. What is du? 1 dx. Good.
Yeah.
Gotta have that dx. Okay. Now V is the antiderivative of the sine of X. So it's the integral of sine. That's why I said these, you got to know that those, we did that pre-quiz. What is the integral of sine?
Negative cosine X.
Negative cosine X. Okay. Any questions so far? U X dV sine of X dx. It's the whole, we have to make sure we exchange everything in the problem. Okay. So now when I go to solve my problem, I get the integral X sine of X dx. This thing is U. And this part is dV. So now this equals, what do I put?
So going with the equation, can you hear me? Is it too loud?
I can hear you clearly.
All right.
I can't see you.
Sorry, brother. You hear me?
I can see you now.
All right. So to go with the equation, you will have to put it as So you would do. You said you. So you do. Wait. No, wait, hold on. Going with the equation, you would do UV subtracted by integral of V du.
Good.
Correct?
So, yep.
So you'll do X times sine of X subtracted by.
Okay, X times what?
Sine of X.
That's dV.
Which is dV.
I need U and V. I need U.
So would it be X times negative cosine X?
That's right. So I got to do negative cosine X. That's the V part. So that's the V part. Then I have to do minus the integral of what? Diarra. Minus cosine X. So that's
so
V.
Change to positive cosine.
Negative cosine X. du, and du is?
dx.
Yes. Okay, so then this part is v, and then I need du. Okay, it is straightforward substitution. U dv is equal to u times v minus the integral of v du. Just get it on the paper.
So wouldn't that, sorry, I might be going too fast, but wouldn't that just equal to negative x cosine x?
Okay, good. So now the next line is to simplify. So I get the integral of sine of x dx is negative x cosine of x minus minus gives me a plus the integral of cosine of x dx. What's the integral of cosine x?
Negative sine x? No?
Sin x?
It's just sine. But good guess. So now I get the integral of x sine x dx is negative x cosine x plus the integral of cosine x is sine x. And because this is the most general antiderivative, I add plus c. And we are done, period, done. Okay. All right, here we go. Integral of x e to the x dx. Now again, if I let u equal e to the x and dv equal to x dx, then when I find v, I got to get 1/2 x squared, and that's starting to look uglier. I didn't added a power, so I don't want to do that. We want to make life simple. Let u be x if we can, and then let dv be e to the x dx. Okay, so now u is x and e to the x dx is the whole thing that's left. Once you choose u, dx is whatever's left. dv is what's ever left. Okay, so now what is du? Gotta find du. Gotta find du.
I'm sorry, Professor, you still writing?
Eric, you're breaking up. Ezekiel, that's Ezekiel, you're breaking up. What did you say?
Can you hear me now?
Yes.
Du is 1 dx.
Okay, so du is dx. And what's the integral of e to the x? I've been feeling this.
So you're asking for the anti-derivative, correct?
Antiderivative, that's right.
So
Whenever we do
wouldn't that
this,
just be the natural log of the absolute value of x?
you making life real hard.
Me?
You made life real hard.
What I
What is
do?
the VEX?
The integral of e to the x is itself.
Professor, we just did the anti-derivatives. And you're right. Okay.
I don't want to, I hope I'm not making hideous mistakes with y'all, because that's not going to help you at all. So yes, the integral of e to the x is e to the x. Okay, so you're just finding the antiderivative. Here you're finding the derivative. So you find the derivative on this side. And you find the antiderivative on that side. That's why I write it like that. U goes to derivative, V goes to the antiderivative. Okay, let's put it together. This is the integral of U dV is equal to UV minus the integral of V du. So we got to plug everything in. So please plug everything in. Plug everything in and tell me what you get. I'm not asking you to simplify it yet. Okay, thank you, Juan. Alan, where are you lost? Is Alan here? Where are you, Alan? There you are. Alan, did I lose you on the formula or did I lose you on the derivatives and integrals? Can you help me? Okay, I got you. Okay. All right. Anybody have an answer? Anybody have an equation? Did they put everything in yet?
The equation be x times e of x subtracted by the integral of e of x.
Okay, x e to the x dx is equal to, what'd you say?
So it will equal to x times e of x subtracted by the integral of e over x.
Dx. Make sure you put the whole thing in. Don't forget that du. That du is important.
Dr. Rod, is it okay if we also mention 1 dx or it's
Please
just dx?
don't put the one.
Okay.
No ones. Okay. What's the integral of e to the x?
Itself.
X.
It's good. So we get x e to the x dx is x e to the x minus e to the x plus a constant, and we're done. Okay. All right. I'm gonna make it a little harder.
Yeah, Professor. It's just my problem is so for instance, the last problem that we did, you said u equals x, and we said the u and du, we're basically finding the derivative. But if I do recall, like a couple classes ago, you was like, the easiest way to find u is to find the most complicated problem. So
that was when, okay, so that's when you're looking at a chain rule problem.
okay.
For these problems, u is generally the most simple thing.
Okay.
Usually, okay? Yeah. For these type of problems, u is the easier thing, the easier function. Can I scroll up to question 1 again? Yes. I'm not sure how far up on question 1 you need me to go. There we go. There's question 1. Okay. All right, what do we do? Let's see, Gustavo.
You say u equal to x squared and dv equal to ex dx. That'll make du 2x dx and v ex.
Okay. Integral of u dv is equal to uv minus the integral of v du. So what do I get? Substitute. Go ahead.
You get, so after you set up the equation, you're gonna get x squared ex minus integral ex 2x dx.
That looks good to me. Simplify it.
So then when you simplify it, you're gonna end up with x squared ex minus ex x squared plus c.
Okay, I'm gonna move the 2 out.
Okay.
And then I get the integral of x e to the x. Don't forget your x, Gustavo.
Okay.
I need that x. Need that x. Okay. So now what happens? That is another integration by parts problem. So you would compute that. So if it's x squared, you're probably going to have 2 integration by parts problems. Okay, here's the thing. We already computed that. We just did it. There it is. There it is. So we already know that the integral of e to the x is x e to the x minus x. So I can now put that in. So now I get the integral of x squared e to the x dx is equal to x squared e to the x minus 2, and the integral of x squared e to the x we just did. Oh no, that's from my other class. That's not cute. That's not cute. Let's go back to here again and do this again. Okay. All right, so that was the integral. So this piece, if you notice, the integral of x e to the x dx, we already computed. It was x e to the x minus e to the x. So I just grabbed it from the previous problem and stuck it in. If I had not done that, I would have to compute that. So I get my final answer, the integral of x squared e to the x dx is x squared e to the x minus 2x e to the x plus 2 e to the x plus a constant. Okay, any questions?
For the parentheses, when I was kind of confused but like e times e to the x minus e to the x is 1.
Where that came from?
Yeah, or how did you separate that?
Okay, so the integral of x e to the x dx, that was the second integral we did. There it is.
Oh, okay.
That was the second one we did. So all I did was pick its answer up, x e to the x minus e to the x, that was his answer, and stuck it in for the integral because I know the answer already.
Okay. Thank you.
And then I just multiplied it by -2. Okay. All right. This one is a weird one. Okay, and the reason why this one is weird is because it looks like there are only two functions. I'm sorry, it looks like it's only one function, which is the log of x. So if the log of x is all I have, I need to make that thing u. And then whatever's left is dv. That's all I have. I don't have anything else to make u. I can never make u dx. I can make dv dx, but I can never make u dx. So therefore, the u has to be the log of x, and dv has to be x. Okay, find du and v. This is why I did that pop quiz, because that pop quiz you got to be able to do the simple little things in order to get the bigger picture. Okay, Xavier, how do you feel about differentiating log x?
Well, not great right now. Only
Okay, so this was okay. This was one of the things.
Constantly crashing.
Oh, okay. All right. Anybody else want to give me the derivative of log x?
Can I try?
Yeah, what is it?
Is it the 1 over x?
1 over x.
dx?
1 over x, what dx, girl, I'll get ready to say, come on now, you know what you got to put there. All right, let me see. Maria, are you on here? Think I saw you. Yeah. Okay, so what's v?
That would be the antiderivative of dx.
Which is the antiderivative of 1 dx.
Know that there is more than just a human presence in this building.
So that would be like log over x plus c.
Okay, good. X plus c. So this is just x. Great. That's it. It's just x. You're integrating 1. So you're finding the integral of 1 dx. That's just x plus c. Okay, so we're good. All right, so here we go. The integral of u dv is equal to uv minus the integral of v d u. Plug it in. Maxine, when you finish plugging it in, tell me what you get.
Okay, so I got inverse x times x minus the integral
Wait a minute,
x.
you got inverse x?
Oh, the natural log of x
Okay, the natural log of x times x.
times x
Okay. Go ahead,
minus the integral of x times 1 over x dx.
That looks beautiful to me. Okay, promise me you'll never call that the inverse of x again.
I promise.
Okay. Okay. All right, so now we get the integral of the log of x dx is equal to x times the log of x minus the integral. Oh, the x's cancel. So I just get the integral of dx. What's the integral of dx? We just did it.
It's just x.
Just x. Plop on that plus c and you got an answer. Okay. If I gave you, I'm not going to do this problem, but suppose I gave you, what is that? That was number 4, number 5. How many times am I going to have to do integration by parts?
What do you have to do it 3 times?
Exactly.
So it all depends on the exponent of the x.
Yes. Okay. So now I'm going to show you. So I think everybody's getting the hang of this now.
I am.
Okay. What did I give you before? X cosine x? Okay, so I'm going to need to do integration by parts. Two times. Okay, so we do this. We're going to let u equal dv equal du equal, and V equal. And while y'all do that, I am going to take roll. Okay, who's gonna give me this? I want somebody who hasn't talked today. Who hasn't talked today?
Professor, are we doing 5 or 6?
You are doing 6.
6. Oh, okay.
Yeah, I already started with the UDV thing.
I can give you
So
U, D,
wouldn't
U,
U
UV,
be
and V.
X squared?
Okay, U is X squared. Go ahead.
And DV is cos X.
Cos X dx. Got to whole thing. Whole thing. Keep going.
DU is 2X.
Keep going. 2X.
DX.
Thank you. We need that. Okay, and V is
Wouldn't it be sine X DX?
sine of X. Okay, good. All right, so now put it together. The integral of U d V is equal to U V minus the integral of V d U. You need to be able to say it just that quick. That's that easy. Let it roll off your tongue.
Is it x squared cosine x dx equals x squared sine x minus sine x 2x dx?
X squared sine X minus the integral of sine X times 2x dx. That looks good to me. So we have the integral of x squared cosine X dx is x squared sine X minus 2 times the integral of x sine X dx. So what is this?
Another integration by part.
Exactly. Okay, so this is another integration by parts problem. So you would actually have to compute that. But luckily, I think we did that in the beginning of the first thing we did. That was the first thing we did today. So we've already done it. So we can just plug it in. The integral of x squared cosine of x dx is equal to x squared sine X minus 2. And what did we get for that first integral? We got minus x cosine X plus C plus sine X. We got minus x cosine X plus sine X is what we got before. Get rid of that, child. and then plus C, because that's what we got from the original. So if you remember, go back to the beginning of the problem, this part here we did, and this was the first problem we did. So we're just plugging it in, just plugging in what we are. Oh no, put that back. Okay, it won't put it back. Okay. So we got the integral of x squared cosine x dx is x squared sine x plus 2x cosine x minus 2 sine x plus my trusty constant. Okay, so far so good. All righty, here's where life gets hard. Okay.
Dr. Bob,
Yes.
I was wondering, when you're integrating by parts, how do you know when everything is completely without subjacence? Like some of the last problem, we had to integrate by parts 3 times.
When there's nothing, when there's no more integrals. So right now, I still have the integral of x sine x dx. So I have to compute that integral. So now I go off and compute that integral and then plug it in. But if you notice right here, at this point, the only thing left, the only thing left for me to integrate was dx. Once I did that, I was done.
Okay, thank you.
All right. So it depends on what's left. Okay, number 7 with 1 minute left. Okay, so now this one doesn't have x squared, x cubed, or x in it. I just have e to the x, and I have sine x. So what I need to do this problem is I have to pick one. Pick u or pick dv. So let's say I like to pick u to be the sine of x. I think, no. Where did I pick u be? Yeah. Okay, you are to compute that integral, and this is where we will start. We will start tomorrow with this integral. I know, and just see where you are, and then you can work with Mr. Samuel. Okay, so I will see you guys tomorrow.
Wait,
We're still going to collaborate, yes?
Hold on a minute. Hey, baby. What are you saying?
Are we still logging into Blackboard Collaborate?
Oh, yes. Tomorrow, Blackboard Collaborate.